interview problems. And hi, YouTube. If you're watching on YouTube and live, you want to interact with me and say something in the chat, then go to Twitch, because the chat is unlocked there. I mean, the chat is there. Hi, Veyman and Lakshai. Hi there. What's up? There are 2 people in the chat, but only 1 viewer displayed on Twitch. That's interesting. What are we doing? Google interview questions, hard questions. Plan for next week is easy Google interview questions. I want to see how both streams do. So next week it will be just problems from LeetCode. Hi, Storm Prod Code. I filtered problems only by Google and will choose something, as the title suggests, hard problems. And those are more interesting, and there is bigger variety than with LeetCode problems. Hi, Xal, Arjun, Habalro. Hello, everybody. How do they get their list? What do you mean? What kind of list? How binarysearch.com creates this list? It's, it's all from the internet. Somebody posts on a forum that they were asked this question, and then it's free real estate. Is it more accurate than LeetCode for restating asked questions? I don't know. I heard that LeetCode isn't that accurate. I don't know if this one is, but there is at least some merit here. And I chose for hard problems this platform over LeetCode because in LeetCode, you only get dynamic programming in hard problems, and that's it. At least recently. Yeah, I forgot to put background today, so there's non-black background today. It's still the same room. Yeah, I'm not taking suggestions now, unless you want to suggest something hard from this list. Right. Yeah, let's see this. Apparently I solved the first one. I will read a problem, and then if it looks nice, then I'm going to do it. Maybe I will skip. We'll see. Yeah, we do binarysearch.com or IO today. And link is not yet updated. It's an old link. Oh, can the link of this list? Sure. How is that hard? That is only sliding window? Oh, I didn't read the statement yet. But believe me, binarysearch.com has some very hard problems. For now, that's the list. I will hide the chat later if I'm going to focus on solving some problem. In this list, can you choose problems related to this joint set? No, because that would be a hint. No, I'm going to solve them randomly. Integer k and list of integers return the length of the longest sublist that contains at most k distinct integers. Well, it's not easy. Well, if you know unordered map, then this is easy, right? You need to maintain. Let's skip. Let's find something harder. Mad Max. I will check out a few problems, then we'll choose something. Yes, videos are later available on YouTube. Night K, if you have some suggestions, say something more about it. Binary search, good for competitive programming? Worse than code forces. Maximum values of each sublist of length k. This is the well-known problem of monotonic queue. Let's find something where we need to think rather than know a particular algorithm. Length of the longest arithmetic subsequence. Easy DP. Largest rectangle submatrix. In what complexity? That's something. Eventually I will set for a single problem, you know. It's a problem I'm struggling from past 1 month. Grab the ones. But it's marked as medium. And didn't I discuss it? I don't know. It isn't marked as hard, and I don't see a mark that it's Google, so for now I'm skipping. I can help you via Discord later for that particular problem, because I know it. So Knight, I know the problem you're asking about. Go to Discord server later. Yes, there's no chat option for YouTube, only on Twitch. Shortest bridge. Let's think about this problem. I don't, and also maybe we'll solve harder version. Shortest bridge. Here's the link. There is a well-known problem on LeetCode, islands, where you need to run some kind of graph algorithm, or DSU, to find islands in two-dimensional matrix. 1 represents land, 0 represents water, and then you just need to there find the number of connected components or something like that to find the number of islands. And that's what I would call very standard by now. We need to here find the shortest bridge that connects two islands. Right. What is this? Then from 1, I guess 1, 2, 3, like how many zeros we need to cross from one island to the other. Find the shortest bridge. All right. Did I solve the E problem? No, I didn't spend time on that, but if I do, I will likely record it. All right, let's focus on solving this problem for a little bit. So for now, I'm not answering random questions from the chat, but hello everybody. Well, we can still run, we can use BFS or DFS or DSU, also called find and union, to find islands in two-dimensional matrix. With BFS or DFS, it's starting from every cell, vertex of a graph. If it's not visited yet, then run something, let's say DFS from it. Always check 4 neighbors in all 4 directions. If there is a cell there, it's land, and it's not yet visited, then go there. This is how you find connected components, which are called, in this problem, islands. And the complexity of that is just of size of the grid, which here is n times m. N is height and m is width of the grid. The number of vertices is n times m. Right. Then brute force that we can do is for every island we can run, we need to find the shortest thing. Okay, maybe the very slowest possible brute force is for every pair of islands, find the shortest path between them. And to do that, we need to run BFS from one of them. BFS finds shortest paths in a graph without weights. If every cell has some weight, then we need to use Dijkstra. The complexity of this is of number of islands square to iterate over pairs multiplied complexity of BFS. And BFS can go through this whole graph, and this whole graph has that many vertices and also edges. And this is very, very slow. But also stupid. Here, For every pair of islands, from one of them I run BFS to find distance to the other. But as I run this BFS from single island, then I know distances to all other islands. So quickly I can improve this to, for every island, run BFS starting from it. And then you know all the distances, take the smallest of them. That's of islands times n times m. And now we can think if there's something faster we can do, and also what's really this complexity. So how many islands can there be? You can find the shortest one song for now, no spoilers, and I'm doing this for a general graph. This is how I would find connected components and distances between them in some way. I'm solving a general problem of there is a graph, some vertices are allowed and they create connected components, and some are bad and you only can go through them. Something like that. What's really this complexity? Islands times n times m. Well, what can be the number of islands? If they are, like, they don't touch each other, but they are, what happens if they touch by corner? 4 directions. All right, if they touch by corner, then they are not a single island. Then if we have a dense pattern like this, like a chessboard with white and black cells, then every second cell is an island. So this is of n times m multiplied by n times m, which is too slow for these constraints. It might just work. Oh, it is guaranteed that there are 2 and only 2 islands. That makes the problem easier, but we'll try to solve it without that. So this, during an interviewer would likely stop me here when I wanted to say, what do we do, how many islands there can be. Because of this, so this, then my solution is already n times m. Sure. Because we have 2 islands. From one of them we run BFS. By the way, running BFS from an island means that this is called multi-source BFS, where if you have multiple vertices in a graph, let me draw something. Right. If you have a graph, doesn't matter what it is exactly, and you want to say that this is some kind of connected component, and from there you run stuff, you run BFS, then for each of them you need to say distance 0 in BFS, put all of that in a queue for BFS, and then just run BFS. Those vertices will get distance 1, then 2, then 3. This is called multi-source BFS, and it's not really harder than standard BFS. And when I said run BFS starting from an island, I meant that every cell of an island gets distance 0, and then we put all of that in a queue and we run BFS. We are done with this problem from the website, but let's do some follow-ups. What if there are more islands? Right. This I limited by nm squared. Maybe this is actually a bit smaller than that. Why did you remove the background? Sorry, I didn't set it up today. I was lazy / I forgot. All right. This is slow, but also in this particular case, if islands are that dense, like every second cell is an island, then BFS is much faster than n times m. In BFS, I need to stop whenever I reach another island. In this case, as BFS complexity, so this second part would become just constant for this particular graph. Because of that, let's for a moment investigate if maybe this can be limited to something smaller. To be honest, I don't know. Everything else I said so far was easy for me and I knew it immediately. Here, I have no idea. Let's spend a minute or two thinking about it. Maybe we'll limit the complexity further. BFS more beneficial than DFS because BFS computes shortest distances, or just distances to something. DFS doesn't. DFS is there only to check that something is connected, that you can get something. If you want to traverse a graph in any way, DFS is fine. But if you want to know distances, which means distance is length of shortest path, BFS is for that. Whenever you need some shortest distance, BFS. Or Dijkstra if the graph is weighted. For multi-source BFS, do you also have to do multi-destination for destination island? Yes and no. Multi-destination is much easier than multi-source. Multi-source BFS just means how we... it means that we initialize BFS in some special way, but inside, for every next cell, what I do is for every next processed / visited cell, if it's land, but not a starting cell, then finish. Not a starting cell, it just means the distance is not 0. So when I see a cell row column, and for this is a new, so is top pair in a queue, in BFS queue, then we do something like that. If type of row column is land, because here it means what, 1, but I'm writing in pseudocode here, kind of, and what distance of row column is not 0, meaning this is not the starting island, then we finish because we found the closest cell in some other island. I'm not going to now explain 0, 1 BFS because that's something completely else. Multi-source BFS is just having multiple starting vertices. Many of them start in a queue and all of them have distance 0. That's it. Right, back to this thing I considered for a moment. So is it true that if there are a lot of islands, then always BFS will be fast? Maybe. I would say analysis is something like that. For every island, the complexity of running BFS from this island is, let's say, we'll touch cells of this island and some radius outside. And I think that those radiuses, or radii, they almost don't intersect. If that's the case, then actually in total, question mark equal, it's O of n times m. I will draw what I mean here. And for that, I need a bigger drawing. There is some connected component here, some islands, maybe in yellow. Some of them can have holes. It's possible that this is an island. Yeah. Even if there can be a smaller one here inside. So the input is like this. Right, all of those are islands. And now I think something like this is true. For every island, if we run BFS, then we go in layers. The island itself is 0th layer, but then we have here the first layer, cells to which we can get in a single move, something like that. Then there's the next layer, and so on. And eventually we will stop when we reach the closest cell. And then the complexity of BFS is the number of cells visited here. Let's say for this top left island, we did this thing, and each of those will have some kind of layer. I mean, some kind of radius. This one did that. Then there's this yellow thing, this something like that, and so on and so on. Like everything should barely touch something. And I claim that other than the boundaries, like if all of them get back by a single step, maybe these are disjoint. Or like everything has here, like every cell is included only in constant number of these radius areas. I don't think it's that easy. Seems spooky when islands have holes. Well, for sure it would make any kind of analysis hard. I'm making my life harder here because nothing like that appears in the problem. I'm just thinking out loud if this is true. That could be like a theoretical open-ended question asked by interviewer to see if you're able to at least approach this question in any way. I don't want to I can help. So what, Andrew, if you say that you know a proof here or a counterexample, then sure, say it. Yeah. Maybe this leads somewhere. Maybe here we can prove that every cell will be visited only like 4 BFSs, and then that's O of n times m in total. I don't know. And possibly now I would spend like half an hour trying to prove it. Proofs are hard. Yeah, problem description is this. So we wondered if running BFSs from every island until we hit the closest other island, then if it's in total amortized good complexity. I don't know. Maybe. All right. But we solved anyway this problem in n times m because there are only 2 islands. And this full problem for multiple islands we did in this complexity. For every island we run BFS. I wonder if maybe it's possible to do kind of both at the same time. Let's try that. Let's remember what they ask us about. Can I control C this? Yeah, I can. They ask us about the distance between two closest islands, right? What if we did this? In our queue, well, actually, let's start from all the islands at the same time. So for each of them, for their cells, we write the distance is 0 from the start. So this is multi-source BFS. Then the next layer is, of course, full of distances 1 and so on. But other than the distance, we also remember from which islands this came. Let's say that everything here is yellow, but this one is, say, blue. And I have distances 1 here, then there will be 2, and so on. And this is equivalent to saying that those islands expand. Let's say that every second, every island expands by 1 in all directions. So every cell makes all the neighboring cells sick with the same color. Then the question becomes, after how many seconds 2 islands will meet? And that's it. Like plus minus 1. The question is, like, if it's something like this, this is one island, this is the other, then after 1 second, they both try to enter this cell, this middle cell. So if they both try to enter the same cell, apparently a moment ago they were like 1 unit away from each other. And if the situation is like this, let's move this more to the left. And this is an island, this is an island. So first they wanted to visit those, they did. And again, those, I also keep some colors. Let's say this is blue and this other island was white and this is white. Now they try to enter each other's cells. That means the current distance between them is 0. In this example, after 1 second, blue and white are neighboring with each other, so the total distance is 2. In general, if they meet after t seconds, then the distance will be twice t, because each of them made t steps towards each other, and possibly +1 for this case in top right corner, this thing, if they in the next second tried to both enter the same cell. And that's in total n times m, just size of the grid, because we will visit every cell only once, or twice, because at the final second 2 neighbors will try to enter. And I think that's it. We solved much harder version of a problem. So assuming that nm are up to 1000 and there are more than 2 islands. Here they said it's only 2 of them. I need to automatize this process of displaying or hiding the chat. Only to make the problem a lot easier, of course. While there will be twice t plus 1, this is exactly this case from a moment ago, the one drawn here on the right, where like if the distance between them is even, like here, then eventually after t seconds, some 2 colors will be neighbors with each other, while white will try to like check blue as a neighbor, and blue will try to check white as a neighbor. If that's the case, then we know it's even. Otherwise here, like, again, this was blue. I need to hide you. If this is the case, so both at the same second try to enter the same cell, this is the +1 case, where t seconds from before they got to this situation, and plus this 1 more unit, it's +1. We are checking the distance from any island to any other island. That's what we're solving. And mark me in Twitch, like right at Ericto, so if a message is to me, it would be better visible for me. Can we run a star with heuristic being the distance from the cell in the other island that is closest to the first one? I guess we can do a lot of stuff, smart stuff here. I don't know if a star will be the best, because you kind of don't... If you want to start from every island, that's not better than what I described here. So expanding them at the same time. There are a lot of properties about the grid. Like starting from this cell, every next layer is very regular. This is the first layer. So vertices at distance 1. This is the second layer, and so on. So you expand this diamond shape, and you check when for the first time you see another island. Also, for 2 different cells, it's very easy to calculate the distance between them, because that's the difference in columns plus the difference in rows. Both these might lead to some insight that we couldn't use in a general graph, but we can use it here because it's a grid. Anyway, we cannot solve problem faster than n times m, like I described, because we need to read the input. Every cell of the input matters. You cannot have worst case better than what I described. If the islands are concentric, then what? What do you mean? Well, maybe we'll just check. I don't know what concentric would mean in this case. Yeah. So that like one island within the other, this is what you mean? Yeah, everything will work the same way. how do I construct the bridge? Good question. I mean, it's not that I understand where the island has the outside. So imagine that, let's say this is one island and this is the other. Let's say something like this. Actually, if you want to understand where island has inside and outside, that's very hard. I would say, maybe not very hard, but hard. Here, expanding just means running BFS, multi-source BFS, so every cell will check all neighbors. After 1 second, this is where yellow will expand. Every yellow cell kind of infects all the neighboring cells. This is what you do in BFS. This is just running BFS with some extra info stored. And white also infects neighboring cells. Yeah, if you have this kind of nested donut, they will meet after distance over 2 seconds. If they meet after 5 seconds, it means the distance was around 10. One went 5 units towards the other, and one went 5 units towards the first one. In the harder version, I don't know what is the harder version, but this problem we solved also if there is no condition about 2 islands. Cool, let's move on. Should I implement anything here? Chat, do you want me to implement 2 islands version? I think we should skip maybe some. I'm not saying that I will not do any implementation today. Implement, because you know the 2 islands is standard compared to everything else we talked about here. Give it as a homework. You can always solve stuff as a homework. By harder, I meant if there are more than 2 islands. Yeah, then we solved it. No, we are not doing 2 specific islands. I described stuff here. We are expanding all the islands. This is like multi-source BFS, and every cell in Q, we know the distance and like group ID or the color. Imagine that everything has its own color. This is what we're doing. And when expanding, we keep the color. Color just means ID. All right, I think at least half of you agrees with me that we should skip. So we skip, but you know, you can go to this, to editorials. No editorials. Oh yeah, there are editorials. There are a lot of codes there with explanations by community. So you can go there. Cool. I refreshed to display the fact that I solved a problem, but I didn't really submit. Implementation will be messy. It just like, if you want, if implementation isn't obvious for you, then solve lead code problem islands. This is the standard problem about DFS or BFS in the grid. I will paste this in the chat. Practice problem. Don't go to an interview without knowing how to solve that one. If we select points which has both 0 and 1 on its sides, we will get the boundaries of the 2 islands. Yes, but that's not needed. BFS works. BFS handles the fact that it goes to unvisited neighboring cells. And no lead code today. Next week, I will do easy lead code problems. Hint for this one. Knight, why are you giving me random problems? I don't have time during a stream to look at your problem and give you a hint. Sorry. If you have a suggestion for a nice problem for me to solve here, a Google hard problem, then sure. Let's go to the bottom of this list. I don't know how this is sorted. By time, maybe. Fix flight itinerary. Itinerary. Is that a word? Itinerary. Let's see. Given a list of uppercase alphabet strings and edges, I guess we will have airports and flights available. We have a list of airports visited, but there might be misspelled names. Yeah, fine. Update the link. Oh, I didn't update it yet because I wanted to open a few problems and then choose something interesting. But now it's chosen. My recommendation from a freshman software developer student. I mean, there are so many things you can do in programming. I can give you recommendations about practicing for coding interviews, right? That's in particular, like this, the link I'm pasting now is mainly for competitive programming, but it's about principles, not about particular topics. Like you need to try to solve a problem after 20 minutes of being stuck and not knowing how to move forward, then look at the editorial or just the beginning of editorial, just see a hint. No, this is advice I can give you. I will not give you career advice. And Daniel, if you have a good Google binarysearch.com question, then yeah, you can suggest. All right, we're solving this problem. There are flights from Seattle to Jam. I don't even know what that airport is. From Seattle to JFL. Is that New York? And from YYZ to Seattle. And apparently I traveled like this, YYZ, then San Francisco, but actually this will have typos, I guess, and then JFK. We need to adjust characters here in itinerary. What about this?
Itinerary. 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 Itinerary.
I hear only a single
itinerary.
I see itinerary, so I will say itinerary. What is the thing on my t-shirt? It's ladies and gentlemen, this is bear. There's a second part of a text that you don't see. It's from some Polish book. Travel plan. Okay. What about this? There is etern. Can I quickly change it? But I would need to do it in multiple places. All right, but let's see. That they give us a travel plan. I would also need to change it here and a few other places. And there are only some edges allowed. When we are in YYZ, and apparently the next place to visit is SFO, then that's impossible because there is no such edge. We can modify YYZ, or we can modify SFO, or we can do both. I knew, by the way, guys, I knew the meaning of this word. I didn't know how to say it. Just didn't know how to pronounce. I saw it a lot of times in emails, so for traveling it's important. And yeah, we can try all the possibilities, obviously, for all the changes. What did we have? We start with YYZ, then SFO, then JFK. Let's do this in any complexity with any solution. For every character, I can consider changing it to any other character. Maybe this will be A, this will be A, and this will be B. So do all of that, then check edges. check if edges indeed exist. This is terrible, and it has complexity 26 possibilities for every character. The number of characters is 3 times the number of words in travel plan, which is n. That multiplied by something small, because we then need to check if those edges exist. We don't want that. That would work for n up to, what, 2 or something like that. It will be much better if we only consider changing YYZ to something that exists in edges. Assuming that there are at least 2 cities, then for sure there must be edge between them, and then we're limited by the number of different cities that appear here, which is maybe m? Yeah, m. Maybe that's better. So then the 26 to this power, it would change to, I think, m to nth power. N times you have a choice between m possibilities. It's still terrible, but here's how would you implement it? Like, we implement it with recursion. There is no other simple way to iterate over all those possibilities. We check all possible first strings, then all possible second strings, right? So there will likely be recursive function, say search. It has some current index, all the strings. I don't know what it returns. Maybe something more, but now we need to fix what the ith string should be. And this is partially modified array. We do this brute force with recursive function. But as we go, we can as well check if those edges exist, if so far we didn't mess up anything. And then as we move forward, let's say then the next there is some ABC and we correct it to something else. And we decided to modify this to, I don't know, SFK. I'm using random characters. This is something. This is also something, maybe unchanged. When we are here now looking at ABC, we don't care much anymore about this. ABC needs to be changed to something that matches with the previous string, but we can forget about this. And this noticing, backtracking you mean? Yeah, so this recursive function backtracking, because we can break from subcases. Yeah, backtracking. And this is what we always do in competitive, I wanted to say competitive programming, that doesn't make sense. This is what we always do in dynamic programming. We quicker want to consider a lot of possibilities, but the point is that when we look at some element, we can forget about almost everything. So when looking at ABC, I don't need to remember how I changed everything here. I have a lecture on this on YouTube, and there I always tell you to ask yourself a question: what is important so far? So when you look at ABC, you need to know two pieces of information. What is the new version of JFK? How did you change it? That's one thing. And the other, how many changes did you make here? Because at the end you will need to say what's the total number of changes. So the state can be described thus as the number of changes here already, or maybe including that, the number of changes so far, this last string, let's call it, I don't know, S0, maybe last S, the new name of names of I minus 1. And now, well, we are looking at I. If I tell you these three values, where this is number, this is a string, 3-letter string, and this is a number, index from 0 to n minus 1. If I give you those two values, that's everything for you needed to continue. You don't care how exactly those were changed. You just need to Now choose something from ABC that matches last S, meaning there is an edge from last S to ABC, and you move on. Changes is needed because when you get to the end, you want to consider that to be the answer. Do I get paid from YouTube? A little bit. Not enough to sustain myself. This stream is basically free. I mean, it's not for income. All right. The answer to what is important so far is the number of changes we made, the last string, the new version of names of I-1, and the current index. For convenience, I will put index first, because like that's kind of the most important thing we're looking here. And last S, I don't want this to be a string because that's hard to put in any kind of map for memorization, and generally I prefer, not what I wanted to do, I prefer iterative approach. This will be just kind of string ID. I want all of this to be values. By this I mean that, well, there are edges and I can gather all of them. All cities that appear here, so those are allowed. There are YYZ, SCA, this again, GEM, and JFL. Those 4 cities are allowed here, and only they are available. Let's say that YYZ is 0, then this is 1, 2, and 3. This is a graph. Now, I know that I have edges from 0 to 1, from Seattle to GEM, that's from 1 to 2, and Seattle to JFL, 1 to 3. There is a graph with these edges. Vertices are from 0 to 3. And now you have some sequence. You need to make it into sequence of vertices such that there are edges for every consecutive pair of cities. There is an edge. For every next string, I need to turn it into some existing vertex. And I need to minimize the number of changes. There's also this condition, n times m is small enough. The travel plan length and the number of edges. So number of edges also tells me how many possible strings I should consider. And that's important because here index I is up to n and possible strings, the number of this is up to m. This is up to n, this is up to m. So the number of pairs, the number of things you can memorize, so also the complexity, is n multiplied by m multiplied by what's the number of changes you can have. That seems to be n. Possibly you will change n times 3 characters, all of them, but it's better than this. We don't need that because this is something we minimize. So this is state of DP and this is something you minimize. I will do this, define, well, you anyway don't see anything on the drawing. All right, DP of I and SID is minimum possible number of changes so far, so that the previous string, how is it called, names of I? Names of I -1 is changed to string city SID. SID is from 0 to m -1, like here. It is index of a string that we used a moment ago. Now we are looking at a string I, and we need to choose something such that from SID we can get here. So the number of states is small enough. N times m is 200,000 and we can have complexity n times m, at least space complexity. That our time complexity is n times m times transitions. And if this is anything bigger than 1, this is bad. Fortunately, like, I will show you how this is smaller than, how this is also n times m, but this is not trivial. I will write it down, not trivial. This one I will implement. And after at least some part of implementation, it will become more clear what's the time complexity. It's anyway easy to say. It's usually easier to say for iterative DP rather than for recursive DP. Yeah, we have this crazy thing. Let's call it, okay, I can go with this word, travel plan, and there are edges. N is this length, and M is for edges, also size. Maybe I will need to do some mapping from strings to IDs. Let's see. For every edge in edges, there is an edge from edge of 0 to edge of 1. But what I want is I want to gather all those possible cities or names. Let's call it names dot pushback edge of 0 and edge of 1. This is some kind of list, a vector. Now I want to remove repetitions. I don't want to say that there are 6 possibilities here, though I think that this is optional step. If you don't remove repetitions, everything would be fine. Just a little bit stranger to understand, but fine. Still, I'm going to remove them. Remove repetitions. For that, sort. And yeah, in every language, there is some way to do it. This is one in C++. I'm not going to explain it. During an interview, I would. No, I don't want to teach you C++ if you don't use C++. This one removes consecutive repetitions and resize then shrinks it to, because we removed some elements. When now I will print for every string in names, print s. Let's run this. Let's just see that it works for the sample test. Works meaning that proper stuff is printed. No return statement. Let's return -1 just so it would compile. Was it an error rather than a warning? I printed this order: jam, JFL, SIA, and YYZ. Good. This is sorted because I sorted stuff, and repetitions are removed. Those are these 6 strings without repetitions. Cool. Now the actual DP. We need something like int DP. I'm looking at this line. I can even copy it here. If you have some questions now about the code, then you can ask in the chat. I will answer, but I don't want to, switch to anything else. Some questions about random stuff. I need to create what I can be up to n, and string ID up to not really m, it's more like twice m. Let's instead create a variable for that. Names.size. This is the number of vertices, the number of possible strings. We need something like that. In C++, it's better if you use vectors rather than arrays, especially for big stuff. Maybe best is array written with ARRAY. I usually use vectors. Something like this. We need to initialize. I don't yet know how. Then for every I, we need to fix it, use it in some way. For every previous string on position I-1, this might be tricky for I equal to 0. It's not properly defined. We have state DP of ISID. Maybe instead of DP I should say minimum possible number of changes or some shorter version of that, but whatever. And for this will be for now slower than what it should be. Can we simply use a set instead of using vectors? Yes, we can. So the removing repetitions can be simulated by just inserting stuff into a set because it removes repetitions automatically. To be honest, I use the vector because I'm aware that it's faster, like maybe 3 times faster than the set, but this is just because I did so much competitive programming and I care about the speed, not only running time. It doesn't matter. In coding interview, you can use this, you can use set, both are fine. How do you like this site? Good for hard problems. All right. So when I look at some position, let's talk about an example. When I look at this position and I consider the fact that previous string wasn't changed, that would be I is equal to 1. The previous string is YYZ, which is represented by 3. Because here we have 0, 1, 2, 3. Those are IDs of those four strings. What can I do now? SFO needs to change into something such that there is edge from YYZ to SFO. Because they told us in the statement there must be such an edge from first to second string, from second to third, and so on. I can iterate over all strings and check if there's edge, or even easier, just iterate over strings to which there are edges from this one. The most common way to represent a graph is for every vertex to know a list of neighbors. And this is what I will use. So now at position of SFO, I will consider all possible next cities after YYZ. For new S in out edges coming out of SID, I will move from DP of I SID to P of I plus 1 new S. Right. What does this mean actually? It means DP of I plus 1 new S. We minimize the number of changes. Maybe there I already saw some possibility to reach that state in 7 changes, but now I see 5 changes, so I overwrite with smaller value. SID plus, and question marks here, I should put here the number of changes. If I decide to change SFO into, say, SEA, I need to know how many characters I need to change. Well, I can compute it here. I move from SID to new S. Iterate over 0, 1, 2. If names of SID... Let's make this into a function. Diff of names of SID, names of new S. I make too few functions. That's easy. No, not string. It returns an int. It returns the number of differences. Const and reference are just for the speed. They are optional. And well, we can do this if A of I is different than B of I, then increase by 1, return count. This is more general. I could even put like a length. But if we want a short version and we know that there are only 3 characters, then I would do this. This is some ugly one-liner. Plus A of 2 different than B of 2. If this is true, then if this inequality is true, then this is 1, otherwise it's 0. So we can add like that. I'm not saying it's nice, and it doesn't generalize well for longer strings. Okay, one-liner. Possible trick using radix, you can encode the free character uppercase string in the 16-bit integer for constant time string search. You're right, but we have this thing with m, and this is better limit. So, you know, there are that many possible strings. That's 26 to the power of 3, 17,000 something. That's around 17,500. And yes, I can encode it actually in a number from 0 to this. But even better, like m will be a better limit, not m, just the number of strings that appear here. I will not have more than that. So in some tests, my solution will be better thanks to the fact that I don't consider all possible strings, only those m of them. So it's better to only use possible strings, not all 26 cubic of them. Are we done? Oh, and what do we return? We need dp of, now we look at n, because the last I was n minus 1. From that, we move to dp of n. All right, what is the second one? The second can be whatever. I think we'll do something like answer is infinity, and take the minimum among possibilities for what was the last string. Minimum from dp of n sid. I still didn't initialize. Well, apparently I need index I from 0 to n. I will increase this thing by 1. For just standard array definition, it would be like that, dp of n plus 1 by k. And let me see if this compiles, but still I didn't initialize. Out edge is not declared. Oh, indeed, I didn't create them. Every time, what should I do? All right, because I know that there is edge from some string to the other. I don't know about IDs, but I can deal with that. Also, this was just to print stuff. Let's remove it. Or, again, for every edge, I want to do something like this. Out edges from edge of 0, push back edge of 1. This will tell me that from this to that, there is an edge. Edges size k. This gives me a list for out edges of 0, also for out edges of 1, and so on. This is just agency list or vector. But here I want ID of edge of 0, ID of edge of 1. That's easy to do. Maybe now I'm overcomplicated the whole problem. But well, the code becomes long. Every single thing that I'm doing is very standard if you did it a few times. And yes, these things appear, like sorting the names and getting their IDs. Maybe from the very beginning I should use some kind of sort or a map. But if I have a sort list of names, then I can use binary search to find where a name is. So what is its ID? Like if I have ABC, DF, and ZZZ, then I want binary search to say that ABC is on position 0, DF would be on position 1, and so on. Lower bound in C++ does that. It returns an iterator after you subtract begin, it will get an index. Get ID of edge 0. I think it would be better from the very beginning to work with maps and to map from string to string. Just because of competitive programming roots, I want to make things fast, and everything is faster with indices, with values, not with strings. Maps are slow, arrays are much faster. Right, did I do everything? Oh, I didn't initialize. What do they want? Line 25. Something wrong with my lambda function. Why is this a Google question? because Google asked it apparently, and I'm able to believe it. If you're asking why Google asks such questions, I would say that's complicated. Coding interviews are stupid, but they scale well. This is type of interview where you can scale it up and everybody independently will judge various candidates. You cannot really do that well with projects. Yeah, well, get ID. Oh, out, not int. This function wasn't of type int. And 52. Yeah, this should be a comment. I think now it compiles and I just need to initialize. I think that the very first city, it should think that on the left from it, there can be everything. So DP of 0 at this ID is 0. There are 0 changes to achieve that. And now city 0 will think that on the left, like in the example, YYZ will think that on the left from it, there can be whatever. Oh, this doesn't work because there is no edge to YYZ. Damn it. Right. Oh, but it's no. What? I might need to do this. For every city starting from the second one, I will look at the previous one and will do something. That's more complicated than I thought. Can you assign a function to an int in line 23? Oh yeah, that was my mistake. No, that shouldn't have been an int. What about using try? Putting everything in the travel plan in the try. I mean, you can put all the strings in try, but I don't know what that allows us to do it faster. It's not that first character is more important than second. Try is very much related to the order of characters. Like we split according to the first character, then second, then third. What was the binary search method? In a sorted list, you can binary search where an element is. Okay, what do I want? For SFL, I want to say that YYZ was already transformed. But for this YYZ, I should do something else maybe. Right. Yeah, so for 1, I will say this. For S of O, each DP needs to hold information about current new string of the previous string. So I will say that the number of changes needed to achieve this is difference between names of 0 and the itinerary. Also, I should have used this here. Maybe not. Something's wrong here. Diff was, I now want to get names of new S, but previously I had itinerary, travel plan of I. And here we have itinerary of 0 with names of SIT. That's the cost to change what was there initially to this new name. And now this should be good. So I initialize that like that. SFO says that on the left there can be this string, this string, this string, and the number of changes to achieve that is the number of changes from YYZ, being itinerary of 0, to this new string. I think we're good. Do you plan on doing some kind of structured course and monetizing it properly? Yes. There is a way, like, I'm good at competitive programming, and to be honest, I excel at that kind of content. Let me finish this, then I will reply. And the last thing is that right now all the values here are 0, but I want to say that it's infinity, to say by default it's impossible, but I want to minimize it down to some value. And also I don't like infinity because after you increase it by something, you overflow. So in Python, it's not an issue because to infinity you can add 1 and it will still be infinity. In C++, it is an issue. Right, done. Now I can answer that question. Nope. Damn it. In OBS, they still didn't introduce the Control Z button. That's so bad. So bad. Why is this bigger than necessary? Actually, because I only show chat from time to time, I can as well make it bigger. Yeah, regarding monetizing stuff, I don't know if I guess I can say that my life is competitive programming, maybe. So those hard contests like Google Code Jam, and I excel at that. I participate. I organize those contests, stuff like that. Coding interview, I treat more like this field. I treat more like a job to teach other for coding interviews. And yeah, for the past 2 years, year and a half, I'm slowly preparing a platform with a course like that. So it will be a competitor to binary search, to LeetCode, Algo Expert. That doesn't mean that I will then start saying that you shouldn't use binary search or LeetCode. I'm quite open about advantages and disadvantages of various platforms. For example, like right now, Algo Expert is good if you want video content. If you prefer written version, then it's very bad. So yeah, my platform is coming eventually, and then you should all, if you prepare for coding interviews, you should buy it. Online 39 should start with. Oh, never mind. All right, I'm ignoring. I'm not in hurry with this course. It's not that I need money quickly or anything like that. If you go even to my channel, you will see how slow I am. YouTube, was it on second channel? Right. This is a stream lasting 6 hours where I only compared various implementations of binary search, which is a very easy method. I know binary search. When for every topic you spend the whole day for comparing implementations and choosing the best one, and I spent in total maybe 3 days on that, because also outside of stream I did stuff. I read various articles and so on. I compared it for various LeetCode problems. Then in total it's so slow. Can we get an ETA price point? So regarding ETA, I don't know. In months. Like Cyberpunk, when it's done. Regarding price point, we're not sure. So I'm not doing this alone. And it's such a hard choice. It seems that the scale of prices for courses is kind of logarithmic rather than linear. It would make so much sense if all courses in the internet were, let's say, priced from $10 to $30 or from 50 to 100, because then it's easy to choose. But it seems that you can take $10 and you can take $1,000. Actually, I was going to, like, for example, in Discord, ask people what they think about it. So when you have any LeetCode or anything like that, there is here CoderByte. Is this a good price? Should we also take something like that? Like, you have Udemy, for example, or maybe Coursera. Not Coursera. So what is the platform where you have $10 for almost every course? It's very cheap, but also I would say, so our platform will be bigger than that. Like, it will not be $10, it will be more than that. But yeah, I don't know what to think about pricing. Some courses are $1,000 or five. Actually, I know exactly 2 courses for coding interviews that cost $500. I don't think they are worth it. Would it be worth it if the platform is the best possible? Hard to say. Please not like Cyberpunk. You know what I meant. They didn't actually went through with the, publish when it's done. Udemy, maybe. Free Code Camp is free. So Free Code Camp, I'm sure that it's good, but not the best, and they don't really have problems. So there is like DS, who does it, and dynamic programming was there recently. I'm only interested in algorithms. There is dynamic programming. This is, if I let me run some.
I want to really visual.
I'm almost sure that this is done by guy from CoderByte. So Free Code Camp for algorithms just takes materials from here CoderByte, and some other one was by Byte.
In
Maybe
these
this one.
first few videos.
No, this is. So I don't know the quality of this. I'm sure that guy from Byte, which is a smaller platform, did something here. I don't remember now what. So, Free Code Camp is just a collection of stuff from other people, and those, I don't think the quality can be ensured that much. But it's great, by the way. And I recommend you to check out this thing. There are courses for free. Generally, everything is for free in the internet. How you earn money now? I give private lessons a few hours a week. By the way, most of the time I say that I don't have spots. If you want a private coaching for coding interviews, I can teach you, but it's expensive, more than $100 per hour. So if you're interested, write to me. More, not equal, more than $100 per hour. It used to be less, but I just have too many people wanting to have lessons. So this is how I live. And YouTube is basically, right now I earn from YouTube $5 a day. It's something. Yeah. It's hard to Google algorithmic stuff here, because not necessarily algorithms will be in the title. But Free Code Camp is great. Code and Code is pretty good on YouTube. I shouted out Code and Code. I think. Now I don't remember that much. I thought that I shouted him out. Yeah, he's a number theory lesson. And I'm even here. There is interview with me, so you don't need to recommend me his channel. Free Code Camp is full of beginner stuff, like the whole text scene, introductory stuff. It's low effort, not worth much. Also, I don't have any plans on monetizing competitive programming lessons, courses in any way. I think I will do everything for free. Yeah, like in Poland, $100 per hour is a lot, really. Like, it's so sick to be able to earn in a few hours what your parents earn almost in a month. It's strange, It is significantly more than a Google engineer earns per hour. I mean, it's less than a good engineer earns per hour. So I adjust with time. My first lessons were for math like 10 years ago. and it was $5 an hour. Price, yeah, it's all complicated stuff. We can talk more about it on Discord later. So let's in a moment get back to solving problems. Regarding different prices in different regions, this is obviously, this has drawbacks in form of, for example, VPNs. Hi, Brazil. No, I don't want Twitch affiliateship because I don't want your money. I mean, I don't want subscribers. I don't want, also I don't want being forbidden from uploading it to YouTube at the same time. Elements of programming interview. Yeah, what about it? Are you asking if it's good? I've read some of cracking the coding interview and it's fine. I can do better. Why don't you work in Ethereum? This is such a strange question. Why do you think it's default to work there? Yeah, I don't want to work in a big company. At least not right now. I'm fine. I don't need more money. Why should I work for Google? Right. Let's move on. This one you're saying is asked by Google, and it's hard. Is it on this list? Toggle. Yes, it is here. Let's see. You were given a string representing a bitwise expression if characters bitwise end or 0, 1, and brackets. You can flip between and or. You can flip between 0 and 1. You want to toggle the value of the expression, so instead of 0, get 1. Machine translation. I don't know what is machine translation. I did machine learning. Hardest project I made. The hardest stuff I made is something from competitive programming for sure. And that's just some crazy algorithms. Like maybe three-dimensional geometry stuff can be very difficult. Streaming with tourist, you can invite him to my channel. If I'm happy to have him. Right. 0 and something. Output 2. Right. So when we have this, and this is the link for you. Sometimes you need to remind me about updating it. Close that, close it, close it. Yeah, by the way, on Discord later, you can talk with me more about this. In particular, I don't know, pricing of courses is crazy. In particular, college in USA is so expensive that really those tens of thousands of dollars are the ceiling. And anything from $10 to that, like it's logarithmic scale, so it's crazy to choose anything. Right, we have this. This is evaluated as 1. Now we need to change few characters. We can change or to end, and we can change 1 to 0. We want to get a 0. In this case, we have some expression 1 or some expression 2. Both are in brackets, expression 1 and 2. And let's say that this is indeed 1. If you want to change this to 0, then if expression 1 is 0, evaluate it as 0. So we have something like, let's say this. Let's say this is end. This is in the input. This is exactly what I'm talking about. It's expression 1 or expression 2. And one of them is evaluated as 0, the left one. This is 1 indeed, but it's enough to change one character like this, and we have a 0. Cool. So if exp1 is 0 or exp2 is 0, I know that I could say if not exp1 or not exp2, but it's not, it's like I'm using language more than code right now, then one change is enough. Change from or to and. Otherwise, if both are ones, then I need to change one of them to 0, or both. I can change both to 0, but I think it's always better to change one of them to 0 and or to end. If I need, let's say, 3 operations to change exp1 to 0 and say 5 operations to change exp2 to 0 from 1, then answer is, I think, 3 plus 1. I take minimum of those, change this to 0 thanks to that, and I also change or to end. Those values are greater or equal 1, because I consider otherwise this would be the case from line 14. So yeah, if we have expression 1 or expression 2 in the input, for each of them we need to compute the number of operations needed to change it from 1 to 0, assuming that they were ones, and the smaller of them I take plus 1. Then problem boils down to computing this for expression 1 and expression 2, the number of operations needed. We need to go recursively there, solve those, and that's it. This problem then boils down to parsing the input. Like every expression like this with binary operations can be represented as some kind of tree, where we have the most important operation between two brackets, or like here, this is between expression 1 being 0 and expression 2 being this bracket thing. Here, this is the main operation between expression 1 and expression 2 on the right. And this can be done in linear time. You can parse such an input in linear time, but is it interesting? It's some good practice. I mean, you need to at least once implement such a problem. But yeah, we can use a stack for that, or mainly a stack. It's easier to do in quadratic time. Linear is harder. So if n was up to 1000 or around 1000, then n square is easier, because we can in linear time pass the expression, find the most important operation, the one between two expressions, and then go recursively. But if you do this linearly and go to every expression, if you have something like a nested thing, let's say you have a lot of brackets here, some stuff, everything here is operations, and then end something, like 1. And then you go recursively to this part. It has length n minus few, and this can have the same look. This can be something and 1. This can be something and 1. So a lot of that. If you draw this like a binary tree of operations, you will have end, then 1, then 1, and 1, 1, and so on. You have a long path to one side. That makes the whole thing quadratic. You need to be more careful. I think this should be implemented with a stack. When you open a bracket, you kind of go down. The next time when you close a bracket and you're on the same level, then you pop that opened bracket. I don't really want to implement it. It's not interesting. Should I? Actually, I think it will be really boring for me. So I will just skip. I prefer problems where it isn't obvious what to do and you need to think about the solution. But here, this kind of topic, if you want to read about it, I would say it's called expression parsing. And the easiest problem like that will be to just evaluate something like this, maybe first in quadratic time. Also, then you can implement a full calculator with some precedence of operations. Please implement. I will not. Even if most people say I should implement, I will skip. String expansion, justified text. I'm looking for something with a cool name. Boxes all the way down. That's an interesting name. Given, by the way, this is still a list for Google hard problems. Somebody was asked in a Google interview. You're given a two-dimensional list of integers boxes. Each line contains width and height. Given that you can put a box in another box if both width and height are smaller, return the maximum number of boxes you can fit into boxes. Well, I know what we need to do, and I'm not sure if we want to do it on a stream. What happened to the background? Yeah, I didn't set it up today. At least please go through editorial implementation. But you can yourself go through editorial implementation, right? Like if there is editorial and it explains what happens, then you can read it later. Yeah, this list is that. Here's the link. Is it not visible from like not having an account? Maybe. It does load. No, it is here. So even if you don't have an account, you have here Google and you can choose. Oh, I see. But apparently if you write proper stuff in the link, then it works. Company equal Google. This works. I wonder if when we hover over Google, oh, maybe not. Sometimes in bottom left link, you see the link address, but no, not this time, which makes sense. This is not a link. This is just a button that triggers this pop-out. Anyway, you can here implement question mark and some stuff. Company equal to Google. Can we choose difficulty? Yes, we can. Cool. Anyway, this account is free. It's not like LeetCode where to know companies you need to pay. Should we move to harder problems? I think this is hard. If you don't do competitive programming, this is a very hard problem. Assuming that I correctly understand what's happening here. I will talk about this problem and we'll explain how it boils down to some other problem and we will solve that other problem. What are we doing today? We're solving hard problems from Google coding interviews. All right. I will give you a few minutes to think about it, how to approach it at all. You can tell me ideas. Assuming that you don't know a full solution, tell me an idea and I will explain if it makes sense or not. Okay, this input represents that. There is a box of size 10 by 10. That should be a square, I guess. Also 9 by 9. And 5 by 5. And 4 by 9. Now we need to put them one inside the other. So that they would fit. Both width and height must be smaller than the other box in which we are putting the other stuff. So 4, 9 cannot enter 9, 9. That's forbidden. But we can put 5, 5 inside 9, 9 and that inside 10, 10. The answer is those 3. That's the maximum number of boxes we can use. If we could reshape boxes a little bit, then we could sort by area. If you could shrink the width and increase the height, we could shrink boxes and we would say that just we put them in this order. But this is not the case. Yeah, I see already proper solutions in the chat. But I told you if you don't know a solution. Is he greedy? Oh, but you need to maximize. When you make some decision, maybe it turns out bad. Take the box with max width and max height as starting point. All right. Then tell me, what do we do here? So let's talk about greedy. Let's say that biggest is 10 by 10. And you cannot rotate. Okay? Then you have decision between, let's say, 7 by 7 or 5 by 9. Which one do you put inside 10 by 10? So you can put something like this or a 7 by 7. You cannot do both. You need to choose between blue and yellow. The thing is, now depending on what are other boxes, smaller boxes, one might be optimal and not the other. And you don't know now which one. Greedy cannot decide between these two. Yes, this is basically Russian dolls problem, like Matryoshka. Right? If next there is also some 6 by 6, then it can fit in 7 by 7. So you should have chosen 7 by 7. But if there is like 4 by 8, then you should have chosen 5 by 9. If 10 by 10 was the biggest, you cannot choose between these two. Create a graph and look for the longest path. You cannot create a graph because it would have up to n square edges. That's too much. You will not fit that in space, I mean in memory, you will not be fast enough. We cannot create a graph out of it. But yes, creating a graph is possible, and because this is a DAG, directed acyclic graph, you can in such a graph find the longest path. In general graph you cannot. That's NP-hard problem, only exponential. We talked about greedy, and yeah, a few people already said sort by one side. This is what we can do. We cannot rotate in this problem. It's written here and it is important. By the way, that's a difference between, that's a big difference between platforms online and a real coding interview, is that sometimes in an interview you will not be given such information and you need to ask about it. You need to ask clarifying questions. And this is a skill you should also be aware of. Maybe practice it by, hiding for a moment all the details about the problem, read this and write down what questions you would have. Yeah, so this is bad, edge is bad. We don't have enough time for that. But we can sort by one side. The sort, let's say we sort by width. Then we will have order here 1, 2, 3, 4. it doesn't matter how we decide ties between this and that. We cannot use both anyway. We will use one or the other. And then after sorting by first side, if we look at the other side, so I sorted by width, so by this. Then if we look at the other side in yellow, the values, I did something wrong. Those values, in this order, they will create some sequence for us. In this case, it's 10, 9, 4, 5. And here's the thing. Except for like ties, that's something to care about. You can grab some subset of it if every next value is smaller than the previous value. By sorting by one side, you guaranteed that this one side will be chosen properly. Every next one is smaller, except for ties. And here, if you choose every next smaller value, then you guarantee that everything's all right with the with this second dimension. And the problem of finding the longest subsequence of decreasing values, so here the length is 3, it's called longest decreasing subsequence. More common version is longest increasing subsequence. And this is something that, in my opinion, you shouldn't learn for coding interview. It's good if you know it, but if you don't know it, there are plenty of other algorithms that you should learn first. Treat this as an extra. And this is nlog n. Nice webcam quality. Thank you. Is it different than previous streams? Where's the geeky black background? Do you really want the background? I can set up the background. Are you happy? You have the background. I'm surprised how many people ask about it. So this is what half of the chat is talking about for the past hour. I just didn't set it up today. And at least now I will not get questions if this is a green screen. What if rotation is allowed? Good question, but we need to talk about this version with rotations. So yeah, let me display this again. The goal is to sort by one dimension, then look at the second dimension by those values, we'll get some sequence, and this can be arbitrary, randomish sequence. It doesn't have to decrease. We need to find the longest decreasing subsequence, and then handle ties. Dark theme enabled. Yep. Is this a green screen? Damn it. I can ban green screen in the chat. All right. Now let's, instead of solving, this is harder version of longest increasing sequence because we need that sort and you need to handle ties properly. Is there binarysearch.com longest increasing subsequence? There is this problem. Oh, it's marked as medium. Oh, because n is up to 1000. Bonus is hard. I think that in AlgoExpert this problem is marked as very hard, right? I don't think that this is the best place to learn longest increasing sequence because there are free videos on YouTube. Yeah, it's very hard. All right, should this be now a lecture of longest increasing subsequence? Maybe it should be a separate video. I don't know. Let's start with n squared. you have a sequence and you want to choose a subsequence such that every next element is strictly bigger. So if you chose 6, then you can choose 7, 8, and that's it. If you choose 1, then you can do whatever. Or in other words, for every number, you decide to take it or not. 6, I don't take. 1, alright, I will take it. This is an example, not necessarily optimal. 7, okay, I take it. 2, no. 8, yes. 3, I cannot because 8 was there. 4, 5. I found a sequence of length 3. That's not optimal, and I just arbitrarily decided. The point is, this is some subset of numbers, and at every moment of this process, you remember the question that I asked in the previous problem, or pre-previous problem, what's important so far in this process, in this recursive process, might I say? Well, it's important how many numbers we already taken, and what is the last one of them. When I'm here in this process of deciding about every next number, it's enough to say I took 2 numbers and the last one is 7. The most recent one is 7. That's the only information I need. Then, looking at every other number, I can say if I can take it or not. And that gives us DP, where we maximize this. So that will be my state, DP of last number. And definition of that is DP of x is the biggest number of elements taken until x. This means that x also is taken, it is the most recent taken number. And that gives us easy transitions. If you choose 6, then iterate over all future values, and if it's bigger than the previous one, we can take it now. Something like this. If the last number was I, and now nums of I smaller than nums of j, then you can, after I, take j. This line means that if there were, say, 5 elements taken, now I take the 6th one. So 6 is possible answer for DP of j. What is roughly rating of this task? I don't know. It's too standard and more educational than about thinking. I remember that in my first years of competitive programming, or just programming in general, I used some Polish platform. I didn't know English well enough. I used some Polish platform, and I knew binary search, for example. I knew some very simple things like BFS, and increasing subsequence is something that I learned like 5 times, because I learned, okay, I kind of understand, I can replicate, I can solve a problem, and then after a month I wasn't able to solve it. Like, I wasn't able to implement it anymore because I forgot what exactly we're doing here. What big secret revealed? Oh, the tourist comment, okay. Yes, Cornfield Chaser, you got correctly what I'm implying. So this is quadratic DP for longest increasing subsequence, and it solves this problem. So actually, let's finish this and submit it because n is only up to 1000. Is there a limit for nums? Okay, but actually my definition is DP of x is the biggest number of elements taken until nums of x. So that this is the last taken element. I will initialize everything as 1 because looking at every number I can say, well, finishing at this number I can take 1 element. Return max from the whole DP. And what about n log n? A segmentation fault, all right. this is my, how do you call it, Achilles. There is some saying for weak point of somebody, for Achilles. He's something at the back of a foot. Yeah, if array is empty, then return 0. What I mean is, in competitive programming, n is always at least 1, or at least they say what's the limit. Like here, n is up to 1000. I don't know what is n, and subconsciously I assume that it's at least 1. Achilles heel. Okay, thank you. Heel. Yeah. Have I read SICP? SICP? What is that? Can you just say what this shortcut stands for, then I will tell you. Is binary search good site? Good for hard problems. I don't think it's good for beginners in coding interviews. It's too much similar to competitive programming. Right. We did it in quadratic time, and now what about n log n? Let's do a 5-minute lecture on this, but I feel that to properly explain it, I would just need to create another stream or lecture with various solutions. Right. Let's take the example from the statement. 617. We try to find longest increasing subsequence in this thing. Here's the idea. It's a bit related to some kind of monotonic stack. Maybe you should first know those problems. Like for every number, find the previous bigger and smaller number. Or sliding window, find maximum and minimum. It's related, slightly related to that. But what happens is, after I consider this prefix, here's info that I need to know. Well, maybe there will be a lot of small values coming, and it's good to start with 1. So let's keep this information. I can choose some numbers in this prefix so that the last chosen number is 1, and the length, the number of chosen numbers is 1 as well. Also, I can choose 1 and 7. Like, sure, I can choose 2 numbers, and they can be 1, 7. I can also choose 2 numbers, and they can be 6, 7. I can also choose 1 number, it will be 6, or 1 number, it will be 7. I wrote down almost all possibilities for what is chosen in this prefix. And here's the thing. This is not optimal, because 1 is better. It's better to finish with 1. If you take one element, then finishing with 1 allows you to do more things on the right. Same here. The last element is important. You don't need to keep 1, 7 and 6, 7 as 2 different possibilities. All right. And now this 1, you can forget about it. You can just remember that there are 2 elements and the last one of them is 7. So this is the only information that you need to keep after processing prefix 617. This information says, I can choose there 1 number and the last value will be 1, or 2 numbers and the last value will be 7. What after we consider 2? So we try to kind of expand this. Well, I can have 1, 2, and that's the length will be 2. I can still have 1, and the length is 1. Having 2 alone is worse than having 1 alone. Can I have 3 elements? No, I cannot. I can still have this 1, 7, where I don't even remember what 7, but this 1, 2 is better. So, remove that. Again, this is not important. Always, I just have info like this. There is a possibility to get a subsequence of length 1, and the last element is something. Here it's 1. There is a possibility of having a subsequence of length 2. We went with 2. Like after we consider this 8, this will be what we keep. There is possibility to take subsequence of length 3. That's 1, 2, 8. and it will end up with 8. But later this can be improved. This is a sequence that we keep and it's increasing. That is, if you know the best possible last element for a subsequence of length 1 versus subsequence of length 2 versus 3, well, it's obviously easier to take one element. If you can take 3 elements, x, y, z, and you end up with z, then in particular you can take 1 or 2 elements like that. And this score is also possible. So like maybe this is also equal to 8, but it's not bigger, because 8 is also possible here. So this is an increasing, or at least non-decreasing, let's say, sequence. Then when a new element comes, like here what comes is 3, we can binary search where this 3 fits in this sequence. In this case it fits here. It means that 3 can follow 1 or 2. And in this case the best use for it is to say that after sequence of length 2 with 2 at the end, we can put 3. So then we have sequence of length 3 with 3 at the end. So this is what happens. In general, it's something like that. Let's say that we can have subsequence of length 1 and the last element is 2. Subsequence of length 2, the last element is 5. 3, 6, 4, 12, 5, 17. And now new element is 8. What does it mean? 8 cannot follow 12. It can follow one of these. So if I take, let's say, subsequence of length 2, so something, comma 5, and now I put 8, then I have subsequence of length 3 with 8 at the end. But I already had better. I had 6 as the third element. So this is redundant. Not redundant, this is not optimal. This is worse. Alright, but this is the biggest number. 6 in this sequence, increasing sequence, is the last number smaller than 8. We can binary search it if we keep this as a sequence, a vector in C++, and say 6 can be followed by 8. And then we have this line means there is subsequence of length 3 with 6 at the end. We can now put 8. What do we have? Subsequence of length 4. So I update. I already knew that there can be 4 elements with 12 being the fourth, but now I see there can be 4 with 8 being the fourth. So always the logic is, in this sequence binary search, the last number smaller than this new value, and number after that replace with this value. Right? 8 goes here, just after the last element smaller than 8. Or in other words, 8 replaces the first number of value 8 plus. One last case is, what if this new value is big? What if this is not 8, this is 30? It means that it can follow 17 even. We already knew there is subsequence of length 5 ending with 17. 1, 2, 3, 4, 5, this is 17, and I can put 30 here. That's subsequence of length 6. And in this case, we expand the sequence. This, if you kept this as a vector, what you do is vector.pushback 30. You append 30. And that's it. And that's nlogn. Yeah, I see that in the chat somebody suggested n-square again. We already did that, but this, thanks to binary search, is nlogn. Let's replace this with nlogn version. This sequence I will call S. You can, well, I don't have a good name. It's increasing sequence. For every new value, x, in nums, what do? We binary search first value x or bigger. Like if there's 8, then we see where is first 8 or 9 or 10 or something like that. That's called lower bound. I don't even need to implement binary search because it's there by default in C++. In this range, find the first value at least x. If you subtract begin, you get index. And what now? Most of the time we do this. I minus 1 was, by the way, the last value smaller than x. And the only other possibility is if this is after the last value. So this is like 30 goes after 17. And now, what's the answer? We wanted the biggest possible length of this sequence. Well, if I know that S0 is smallest possible last value of sequence of length 1, I mean subsequence of length 1, just because indexing here is from 0. Let's say that we have here 3 elements. This S size, if it's free, if it has indices from 0 to 2, then answer is 3. The answer is S size. Like in this drawing, the answer is 6. 30, the last considered element, could be on the 6th position. Maybe later we have something smaller, it modifies some value there. Yep, still 6 is the best answer. Did I miss something? Segmentation fault. What's wrong? Oh yeah, you're right. So I binary search in this sequence I'm creating, not in nums from the input. They are not even increasing. And I cannot sort them because that would mess up the order. Minus S begin, sure. So this now, binary searches in this sequence I'm maintaining, the first value x or bigger. By the way, typing here x plus 1 would mean that I'm allowed ties. But you can think about it later, let's say as homework. What happens if we put x plus 1 here, strictly bigger, but I don't want to spend more time here because any new hard algorithm like that, you shouldn't, I don't really want to teach us small part of the stream. And or upper bound, of course, obviously, but that's only for people who know C++. Now you don't need nums empty check. You're right. I needed that before in my DP. Cool. That's n log n. And by the way, it is not necessarily faster than quadratic version. I don't remember what was here before, because for small values of n, asymptotically better doesn't mean faster. Never care much about this. If you know what's the time complexity of your solution, you're good. And also, other way to think about it is just different kind of DP. Remember how I said that what matters is the current index, let's say, and the last value or something like that? Or maybe not really the current index, but the last value taken and how many taken. And from that we said that DP of last value taken is most taken so far. So this is actually state, and one of those values we can put as dimension of DP. Here I put last value as dimension, and this is value of DP, the int here. When you define something like that, actually it hides two values, two dimensions, last value and this one. And this value is most elements taken so far. But what we could do is kind of reverse it. How many taken among subsequence where you took 3 elements, what do you want to optimize? The last number you want to be small. So this is how I solved it in n square. This is also how you can solve it in n square, but even better, this the other DP has some monotonic property and we can binary search there. And that's very nice. So all my drawings and all of that, it's equivalent to doing DP where dimension is how many taken. This DP array is exactly what I maintain. My S is DP of how many taken. Like I had this line here, I think. S of, let's say 2 is smallest possible value of last element if we take 3 elements in total. 3 being 2 plus 1 because we index from 0. This sentence is exactly the same with this. Smallest value of last number if we take that many. Would it be slower if S was a multiset? Yeah, multiset has a worse constant, any kind of set. Binary search is very fast. N-square solution is fine in an interview. N log n is maybe what you can call this raising the bar question, the most difficult question of a day. Generally, this is example of a bad coding interview problem. I would never ask it if I was an interviewer, because some people know it, and if you don't know it, it's very hard to come up with it. While there are a lot of good interview problems, where it's not about knowing a particular algorithm. This is exactly a well-known algorithm that a lot of people know, so it's terrible to ask about this. But not all interviewers are perfect. Can I explain unbounded knapsack? For sure not today. Generally, for any kind of suggestions, use YouTube comments. I read them, and I'm slow in producing contents and videos. Also because I do other stuff. All right, I think that's it for today. Let's rate somebody in Twitch. Hopefully somebody doing interview problems. There's Sonar Gonul. He often does coding game, simple-ish problems that you can play multiplayer with him. I mean, you race against other people to solve easy problems. So, thank you all for watching. Making an MMO from scratch. I never was into, watching game dev or anything like that for more than half an hour on Twitch. And half an hour was only like once every few months. Puzzle gaming custom engine. But we streamed this guy. We rated this guy, right? What is this? Rolling and responding to 2 sets of dice at the same time.
We need to set it before we call roll the dice. We need to call roll the dice.
I see. I hear echo. I see. All right. That's right. It's quite arbitrary. I don't know the guy. But whatever. Yep. And check out the Discord server, by the way. Link in the description. Bye bye.